and then we'll be done. I'm gonna let you guys read this real quick. So yesterday we talked about bias, yes? And in reality, what I want you guys to think about in general is bias is something that somehow systematically makes your sample not representative of the population. It's usually not intended, okay? All right, so the way we avoid bias is we think critically about how we gather our sample to begin with. And what we do is we want our sample to be what we call a random sample. How many of you guys have heard of the phrase random sample before that? You want the sample to be random. What does it mean to say that something is random?
They're not systematically chosen. There's not a pattern to who you choose.
I would argue that if we're going for no pattern to who we choose, there could be a pattern in who we choose that happens randomly. Yeah? Okay? Like having to decide what is random is like, we use the phrase random sample. We don't really talk about how we get a random sample. Okay, so what are some other words that come into your brain when you hear the word random? Diverse, okay. If I wanted to randomly pick you guys, how could I do it?
Put our names in a hat.
Names in a hat? Okay. If I put your names in a hat, do I have to do anything else besides just put the names in a hat?
Mix them up.
I have to mix them up, yeah? So that it's not like more chance that the people on the top have a higher chance of being selected, right? Or vice versa, like I don't dig, right? Like they have to be mixed up so I don't know who's where, right? Okay? All right. So essentially doing a drawing, that's like practically playing a lottery, yeah?
Pardon the interruption. At this time, if you have not had your picture taken or you want a picture retake, juniors and seniors, please report to the auditorium. Juniors and seniors for picture first takes if you missed it and retakes if you want a new picture. Thank you.
Is that anybody in here? Okay. All right. So that's kind of like a lottery. What if I, let's see, today there's 8 of you. Turns out I have an 8-sided die. Could I roll an 8-sided die a couple of times to pick 2 of you? Like give like 1, 2, 3, 4, 5, 6, 7, 8, and just roll that die? So rolling a die would work. Yeah? Okay. So both of those things use a chance process of some kind. Can me, Miss Meister, with that die, control whether it's going to come up 1, 2, 3, 4, 5, 6, 7, 8? If the bag is well mixed and I reach in and I can't see it, right? Can I control whose name I'm drawing out? Not if it's well mixed. But in order for that to happen, also though, like all the pieces of paper that we write your names on would have to be about the same size, right? Same texture, all that kind of stuff. We would want to make sure every piece of paper feels exactly the same to me. Everybody good? Okay, great. All right, now, sometimes we sample with replacement, sometimes we sample without replacement. With replacement means if Meister's drawing 2 names, after I draw a name out, I put it back in, mix it up again, and redraw. Okay? So In that case, we're always drawing from the same population. Whereas if I sample without replacement, let's say I wanted to pick two of you, and I don't want to be able to pick the same person each time, right? Okay. If that were the case, then the population would decrease with each draw.
So it's sampling with replacement, and you pick a name and you put it back into that.
Mm-hmm. And it turns out that when it comes to sampling 9 times out of 10, I made that number up, but most of the time we sample without replacement because we don't want to sample people twice. We don't want the same person in our sample twice, okay? And whether or not we're sampling with replacement or not does have some implications to how you would describe getting that sample, okay? All right. So, oh, I didn't print these off. Guys, we might have to take a 2-second hiatus. Okay, so here's what I'm going to do. I'm going to pass out a sheet. On the front page are the lyrics to the song Crazy in Love. On the back page is something very similar with the lyrics numbered. Is everybody good so far? Okay. I would like you to have this page up until I say so. Everybody good? Now, our goal is going to be to estimate the mean number of letters in the words of Beyonce's song. Of this song. Is everybody good? Now, could we add up all of these? Could we do every single word in the song? Do you want to? No. This is an example of a situation where taking a sample is the best way to do it, yeah? Because of like the quantity of this, okay? So, what you're going to do is circle. In a minute, I'm going to have you randomly pick 5 words in the song. So you have to do it really quick because I don't want you thinking about how you're going to get your words, right? You're just picking a random sample of 5 words, okay? So I'm going to time you. You only get 5 seconds to do this, okay? And all I want you to do is circle a random sample of 5 words on the other side of the page. On the other side of the page, yeah? Ready, set, go. Stop. Everybody got your 5 words? Everybody good? Okay, so I guess I probably should have done this too. So I'm going to circle 5 words real quick. Ready, set, go. Cool? You guys all saw me do it? Okay, these are the words I circled. You're going to do this for the words that you circled, yes? Okay? The words I circled are I, eyes, row, me, impress.
Wait, we're writing down our.
You're writing down your words, yes. And then underneath each of those, tell me how many letters are in those words. From here, I would like you to tell me the average number of letters in the word. So each of us has a different sample of words, yes? So each of us might have a different average word length, yes? Everybody good? Okay. So my average word length was 3.4. Is everybody good? Everybody have your own average word length. Great. So, did anybody have an average lower than 3.4? Anybody have an average word length that was bigger than 7? Perfect. Okay. All right, so for instance, we're going to make a dot plot for the class. There's Miss Meister's 3.4. Label, what was your average?
4.8.
Carter, what was yours?
5.4.
I'm sorry?
5.4.
5.4? Andrew, what was yours?
4.2.
Ben, what was yours?
3.6.
3.6?
Yeah.
Jack?
4.
4 flat?
Yeah.
Silas?
4.4. 5.2.
Matt?
3.4.
Okay. I feel like my graph looks a little funky with the, what if I do this? Oh, nope, it's not gonna work. Okay, it's fine. It's fine. Everybody good? And based on the samples that we circled, if I ask you, okay, now we have all of these samples, what does this suggest maybe the average of the page is? 4.2? How are you getting that? Kind of just like estimating what's the mean of this graph, yeah? Everybody good? I don't know. I'd put it right around here-ish, right? Maybe? We'll do 4.2. I'm good with that. Okay, great. All right. Now, the next thing we're going to do is use the backside of this, okay? If you don't have a calculator out, you'll need a calculator to do this, okay? I'm going to show you a cool function in the calculator. So what I'd like you guys to do is hit the math button. And then I want you to arrow over so that the PRB at the top is highlighted. Everybody good? All right. Now, from here, let's go ahead and choose where it says option number 5, where it says rand int. Okay. Does most of your stuff ask for a min, a max, and an n? Is that where we all are? Perfect. For your min, go ahead and put 1. For your max, for right now, I just want to show you what this does. I want you to put your favorite number in for your max, whatever your favorite integer is. Does everybody have a max in? Okay. All right. And then for n, just go ahead and do 1. Everybody good? And then just hit enter.
Number, if I enter on what's that?
Okay. So you're just going to do one comma, your favorite number. And at some point, I should upgrade the operating system on your calculator for you. Think of it as like your calculator runs on like iOS 10 instead of iOS 16.
Hey Carter, you need to update that. Gotcha.
Everybody good? And if you hit enter again and you hit enter again, what are you guys noticing it does? It does a random number in between each of those things. Okay? Is everybody good? So, let's say I want to use this idea to randomly pick a different sample of 5 words from the back here, yeah? How many words are back here? So, every single word in the lyrics has been assigned a number between 1 and 297, yeah? So, this time what you're going to do is we want to generate a number between 1 and 297. So, everybody good? So for Carter, yours will be 1, 297. Okay? Go ahead and hit enter. And so now we should all have different. You guys should not have 121 here. Yeah? You guys have a different random number. Okay? So let's go ahead. So I'm going to just write down the numbers I'm generating.
What am I doing?
Good. Okay, so the numbers I generated were 121, 69, 205, 42, and 70. So I'm going to write down what words those are. So at 121, I can count. I have kiss, can, so my average was 2.6. Can you guys figure out what your average of this sample was? And we're going to go around. Levo,
2.6.
Carter, Andrew,
3.2.
Jack,
3.4.
Ben,
3.4.
Silas,
3.2.
3.2, Sam,
3.2.
3.6.
Okay. You guys, how we feeling about this? Is there a difference between the two graphs? Everybody good? All right. Question. You were not supposed to use any sort of strategy to circle your 5 words when you were just eyeballing what is random. Yeah? Now be honest. Did any of you use a strategy?
I mean, just mine were all on the right side.
All on.
The right side of the stanza.
Oh, okay.
I'm not rolling like this center.
Yours were all in the center? Did anybody circle a clump of 5 numbers? Did anybody say, oh, I need to get a long one, a short one, anybody do that? Did anybody take stabs? Because here's what I look at. When I see this, and I see this, and what I'm going to do is I'm going to move this ever so slightly. I can do this. No, I just want to select this one. There we go. So that like the 3s and the 4s and the 5s line up. Are you guys with me? Now, the class as a whole overestimated by a lot. Okay? So the point of this activity so the number 4 is, there's 2 things I want us to see about it, okay? Number 4 is more compact, where I'm going to say less variability. And lower values. Yep. Okay, now, the goal of this activity is to kind of get through, and it doesn't feel this way. It probably felt like you were doing random when you chose your words, okay? But in reality, the human brain is programmed to look for patterns, yeah? We're hoping that's what we try to do. And it's really, really hard for a human being to eyeball what is random, right? In the same way that I can't just go out in the hallway and randomly select kids for a survey. It's not random if I do that. Are you guys with me? Okay. So, what we just did, though, was use a process that you could use to describe how to get a random sample. The way we gathered our samples for this one was your human brain involved in selecting the sample. In other words, did you pick which words you were using, or did the calculator pick which words you were using? Everybody with me? Okay. Now, based on the blue dot plot, what do you think the average words on the page were? 3.2-ish, right? Okay. Right. Now, it's known that typically authors use about the same word length all the time. Okay, like individual words, no, but on the whole, one of the ways they decided was this truly written by, is an unknown passage doesn't match a passage of a different author type thing as they look at average word length, okay? So based on that, it's known that most of Beyonce's songs are 3.6.
Pardon the interruption. At this time, any freshmen and sophomores that have not had your picture taken or are doing picture retakes, please come to the auditorium. Any freshmen and sophomores that are doing retakes or have not had your picture taken, please come to the auditorium. Thank you.
Okay, so based on songs we know that Beyonce wrote Her overall average is 3.64. Do you think our samples give us enough evidence to say that 3.6, that she didn't write this song? Based off of this dot plot, was this song different than her 3.64? Are you comfortable saying she didn't write this song? I'm not comfortable. So I would say we have some evidence that the fact that our overall average was 3.2, which is lower than 3.6, yeah, is some evidence that she might not have written this song. But for right now, I'm going to say, but that's not enough to convince me. So far, are we feeling good? All right. This sample right here was a simple random sample. Everybody good? Okay. And okay. All right, so let's say Mr. Belk, and I know he is planning on doing some of this, wants to gather input about the new cell phone policy for the school year, okay? And we're about 9 weeks in, give or take, right? We're almost towards the end of the 9 weeks. What population do you think he should be interested in sampling here? The students? Is that the only population he should sample? Anybody else? Custodians? Okay. We could just say staff, right? Like we could combine these into staff. That's great. Okay, what else? Anybody else?
Parents.
Do you think he should care about what parents think about it? Maybe parents, yeah. Okay, so how could he gather samples so the easiest, simplest type of sample is what we call a simple random sample. And in fact, for a simple random sample, we start with our population. And from our population, we use a chance process to gather individuals. That's it. It is the equivalent of just throw everybody's name in a hat and draw it. Okay? What do you guys think about doing this way? Certainly, we could get a list of students, like one giant master list of students, staff, and parents. Like just from Power School alone, all of that stuff can get put into a spreadsheet relatively quickly, right? And once it's put into a spreadsheet, everybody's numbered, and we could just randomly select, yes? What do you guys think about that process?
I don't think it worked very well. It's not going to be, there's not going to be an equal ratio of parents to students to staff. And so there's a chance some groups will be underrepresented.
Okay, well, so as we talk about underrepresented, that becomes interesting because if there's, I don't know, about 350 students and about 35 staff members, which is close. It's not quite there. It's probably a little bit different. But just for those cases, should we have just as many staff selected to give opinions as students? No, it should be. We should have proportional representation. Does this guarantee proportional representation? No. It is, however, probably the easiest kind of sample to take. Everybody good so far? Okay. Some features of simple random samples. All participants have the same probability of selection. Okay. The other feature, all samples have the same probability of selection. And I like to think of this as the vanilla ice cream. Okay? It is a good sampling process. Okay? It is, because when you do it well, you're going to do it with a chance process. Okay? However, just because it's a good sampling process doesn't mean it's the best. So some of its flaws are, we could end up with disproportionate groups. Now, the larger the sample I take, the less likely that's going to happen. Okay, everybody good? All right. I want us to be super fresh-brained for stratified and cluster sampling. So let's take a break here and come back, okay? All right. Now, you guys, so the concern if we took a simple random sample is it is possible that we get kind of a lopsided sample, right? Where either students are over or underrepresented and so on and so forth. What could we do to make sure that that doesn't happen? That we don't end up with a lopsided sample? Yeah, what if we took a random sample of students, a random sample of parents, and a random sample of staff members?
I think the same problem would still be there because if it's the same number of people, that would take it.
But you can control how many you're sampling, yeah? Is everybody with me? So we could say so we have students, and then randomly select. And then you have staff, randomly select. You guys with me here? And then we have parents, randomly select. And not only do we have those, but then when we talk about like some of the important characteristics of this sample, you would want your group size, your sample size is proportional for each group. In other words, let's say there's 350 students, I might select 35. Right? Like maybe 10%, 10%, 10% of each group. You guys get what I'm saying there? Okay? So the sample size is proportional for each group. Yeah.
I can see us using this for the stuff, but when would we use simple random sample? Like when would be a good?
He could just take a simple random sample.
Could he?
Yeah. So you're gonna find there's lots of pluses and minuses to different things. Now, here's a way of thinking about it. In this particular example, do you think students have a different ideas about the cell phone policy than staff members? And do you think like in this particular case, there's definitely like some sort of what I'd call the confounding variable. Like these definitely, like the groupings here definitely influence how people feel about the policy. But I could have grouped by grade level. Do you think that there's going to be differences in how each grade level feels about the policy? It would be less severe, right? It would have less influence, I think, than say students versus staff versus, right? I don't like using the word versus because it implies this relationship versus, but you guys get what I'm trying to say.
Yeah.
Okay. Or I could divide you guys up by eye color. Do you think that influences? Would that be helpful? So is when we stratify, that thing we stratify by, we want to stratify by something that we assume has different opinions. Or each group would have different, in this case, feelings. Our variable of interest is feelings about the cell phone policy. That's not to say that doing a simple random sample would be bad. It's not. Is it the best? No. But there's no bias inherently in a simple random sample.
And would the pro be like it's quicker to do?
Yeah, the pro of it is that it is by far the simplest. And if you don't have a variable like which group you're in that is influencing, then not everything needs to be stratified because not everything has an outside variable that you're worried about being represented equally.
Okay. Yeah.
Cool? Hey, guess what? If the groups are proportional, like they should be, the probability of all participants would still have the same probability of being selected. Now, randomized clusters. Okay. This one's a little bit of I would not use a randomized cluster design for this context. Can we all agree on that so far? Okay. So, we're going to still use this context, but I'm going to vary it ever so slightly. And this time what I want to do is I want to talk about how could Mr. Belk get a sample of seniors, a random sample of seniors. So let's say he's trying to fixate on how he gets his sample of seniors, but he doesn't have the time to go through and pick, assign every senior a number and do that, okay? So here's what he's going to do. He's going to take Mr. McCarthy's senior English classes, and he's going to pick 2 of his 5 senior English classes. And to do that, he's going to do so randomly. Is everybody with me? As long as it's random, should that work? As long as he's not, favoring AP English, right? Do you guys get what I'm saying here? Okay? So an example would be pick a class of seniors. Everybody okay with this? All right. So, big idea. You pick an entire group. And you choose that group is chosen randomly. All right. Now, for the purpose of how we've kind of explained this as we're describing McCarthy's classes as seniors. Do you guys see that in stratified, there's a distinguishing characteristic from each group. Whereas right now we're picking an entire group of seniors. They're the only, there's no distinction between, say, his first period, his eighth period, his fourth period. In the way we're setting this up. Okay? Now, typically for a cluster sample, the groups are what we call homogeneous. They all look the same to each other. Okay? And for stratified, by the way, these are called
Pardon the interruption,
strata.
this is the final call. If you have not had your pictures taken or need retakes done, you need to report to the auditorium. Final call. If you need retakes or have not had your picture taken, thank you.
And with strata, there is something that distinguishes one strata from another strata. Everybody good? Okay. Those are the three that the College Board super emphasizes. We're still going to talk about systematic because you're going to see it, but it's not a hugely emphasized thing. I do want to make sure that you can distinguish between cluster and stratified samples, okay? One we select from each group, the other we select entire groups. That's the easiest way to distinguish between the two. Everybody good? Okay. The last one is a systematic sample. This is when you take your sample by taking every nth person. Or, so for instance, if he says, I'm going to take every 10th person that walks in the door in the morning and ask them their opinion. Everybody good? If he chooses to just take every 10th person, is that random? How could we make that random? Well, let's think this through for a second. Let's say he's taking every 10th person, he could be taking the 1st, the 11th, the 21st, 31st, right? That's one possible way he could take every 10th person. But he could take the 2nd, the 12th, the 22nd, the 32nd, or he could be taking the 3rd, the 13th, the 23rd. You guys catch my drift now? So where does the randomly come in? You use a chance process to determine where you start. Does this make sense? When you don't have a list of participants in advance, right? So if you know if he wanted to sample how people felt about the refereeing at a basketball game, he might do every 10th person who leaves the game. So it would have to be somebody who was at the game who wouldn't be able to predict from the beginning how many people would be showing up. So you wouldn't be able to number or do any of that kind of stuff. Everybody good? Okay. Let's look at this example. Tell me, guys, we're going to do this for your response question, and you'll have some time to decompress. Maybe work on your homework, though you'll have some time on Thursday to do that. I know this has been a long block period, and this is just one of those units that it's a tedious one. Okay? All right. I'm going to go ahead and let you guys read the STEM and then part A, and then we'll talk about it. Everybody ready to talk about part A? All right. What do you guys think? What are we asked to describe here, essentially? Keyword? Why would this method is biased? Yeah? So you guys, if we're talking about why something is biased, we want to talk about how is the sample not representative of the population as a whole. Everybody good? So tell me, guys, how are the first 500 people at a football game not representative of the campus as a whole? It could be the team itself. Okay.
It could just be people who are more involved with the sports.
Yeah. You guys, the first 500 people who show up to a game are the real raw ones, yeah?
The tailgaters.
Well, I'm not...
People who like the school.
Yeah, they're going to be big fans of the school. Are they going to say something disparaging about the school? Everybody good? Okay, so we might say,
Wait, would it make a difference? Would it make a difference if it's 500 students instead of 500 people?
yeah, technically. Have I described the source of the bias? Now, have I described the impact on the response variable? Like higher, right? They're going to say higher, nicer things about the school. Done. Everybody good? You get the basics? Okay. Part B we're going to do together because there's very specific things you need to do when describing how you could get a randomly drawn sample. Like super specific things I look for, okay? So, you guys, let's start with how did we get that simple random sample from our list here, yeah? When we used the technology to get there. What was the very, very first thing that happened?
We had a minute on that.
Before that. How do we know what the min and the max were? I told you because I gave you a list with a number assigned to each word in the song, that each piece of my population. Everybody good? Okay. Were these numbers assigned randomly? Nah. Okay, so the very first thing we're going to do is assign each student a number between 1 and 70,000. Create that index of who's who. Okay? Then we put the min and max in our calculator and then used a random number generator to generate my sample, right? You generated 5 numbers, yeah? Okay. Did anybody get repeated numbers? Where you generated the same number twice? Is it possible that the calculator would have given us the same number twice? Okay, so this is one of those things that'll be really, really picky, okay? We want to get 500 unique numbers between the 1 and 70,000. In other words, the min and the max. Now, if you said 500 numbers between 1 and 70,000, ignoring repeats, that says the same thing, okay? But the basic idea is we want to make sure we're not selecting the same student twice, because in this particular situation, they would be sampling without replacement. You need to communicate sampling without replacement. Using the word unique does that. Using the phrase ignoring repeats does that. Everybody good? All right, so what did we do after we generated our list of numbers? We said, hey, which words is that? Everybody good? So, ask the students associated with those numbers okay? Identify those students. And what is the whole idea? What are we interested in gathering about?
If they're satisfied with the appearance of the university, those will count.
So you're going to ask them their opinions about the appearance of the university. Do we get the basic gist of this? If I don't mention the appearance of the university, you guys good? All right? C.
May I have your attention, please? This is the final call. Anyone needing pictures, this is it. Thank you.
Thoughts on this one?
One campus could be like better looking than another.
Yeah, so keep in mind, when we stratified, we said it didn't make sense to stratify by eye color, right? Because your eye color is not going to influence how you feel. We don't think it would influence, that's not something we would anticipate influencing how you feel about the cell phone policy, right? Okay, but so you would want, in order for us to prefer to stratify by campus, there needs to be differences between the two campuses. Everybody good? That's it. You stratify if there's a difference between. Is there ever a time where they might want to stratify by gender? Probably not in today's world. When Miss Meister was in college, it made sense because there were, like, we had co-ed dorms, but there were also, like, non-co-ed dorms. And then, like, if there was a difference between, like, say, those buildings, that would make a difference. But you guys feeling okay? All right. So we're going to spend the next, like, on Thursday, we're going to review for the quiz, / you guys can work on your homework, whatever. I will probably assign the first progress check. Well, I did, because I assigned progress checks from Unit 3 before Unit 2. I'll probably have you guys looking at those a little bit, too, to start firming up. Do you understand the big ideas of these concepts? Okay? But I'm done for today.